this function is a little bit unique because it is made up of two curves. Okay, it is a bit unique. It is made up of two curves. So let's start with the general equation. So let me say A here, the general equation. The general equation. All right, I'm going to use function notation. So the general equation is f of x equal to a over x plus q. All right. Now the definition of q still remains the same as for all the functions we have done up to this point. Q determines the vertical shift. Right. The only new term, which is the one that I will talk about next, is a. So at the bottom here, I'll say where a, put a point, where a is a value that determines the quadrant in which the two curves are drawn. Okay, please be aware that the hyperbolic function has got two curves. Okay, so for you to know in which quadrant you are supposed to draw them, it will depend on the value of a. Okay, I'm going to talk about that later. Then q is the value that determines the vertical shift. Q is the value that determines the vertical shift. The good thing is we have spoken about this in the past. So I'm not going to dwell on the meaning of Q. Okay, so I'll start with the general equation. Now, as you can see, our variable x there, it's a denominator of the fraction part. Okay, it's a denominator of the fraction part. That's one unique characteristic of the equation of the hyperbola. X will be part of the denominator, or it will be a denominator. All right, then the next, okay, just add here on top, just find somewhere you can squeeze this, just put properties. Yeah, just add that at the top. So we'll start with the general equation, then we'll move on to the shape. The shape. So B, we'll talk about the shape. Now, the shape is determined, okay, by the value of A. Okay, so when A is positive, the hyperbola will look like this. You draw the two curves in the first and the third quadrant. Okay, now this function has got asymptotes. Okay, it has got two asymptotes, a horizontal and a vertical asymptote. When A is negative, you draw it in there, draw the two curves in the second and the fourth quadrant. So it has got two asymptotes, the vertical asymptote and the horizontal asymptote. So if A is positive, the graph should look like this one. If A is negative, it will look like that. Okay, if you want, you can put the arrows, but be very careful that the arrows must point away from the axis. Okay. It's not mandatory to put the arrows, but you can add them if you want. So from now on, if you see any hyperbola, it looks like any one of these two. Okay? That will depend on whether A is positive or A is negative. And please don't confuse the meanings of the A for the hyperbola, the quadratic. They are different. Okay, but both of them, they determine the shape. Their unique meanings are actually different. You've got your shape there. Then let's move on to the x-intercept. X-intercept. So see with the x-intercept. Remember, you get this when f of x is 0. Remember that. You get that when f of x is 0. So our general equation is f of x equal to a over x plus q. If we substitute f of x equal to 0, we get a over x plus q. Then the next thing there is to make x the subject. Okay, you just use your knowledge of equations. So we take the q to the left, we get minus q equal to a over x. You can write this as a over x equal to minus q. Okay, let me not complicate things for myself. Okay, then from here, the denominator of that minus q is a positive 1. Then if you cross multiply, we'll get minus qx will be equal to a. What this means is that x is going to be a over minus q. So that's your x-intercept. Okay? You're asked to calculate the x-intercept. You can memorize that equation. X equal to a over minus q. Okay? That's your x-intercept. Okay? Be aware that a can be negative or positive. So depending on whether a is positive or negative, you may get a positive x-intercept or you may get a negative x-intercept. But this is the general equation. Okay, this is the general equation that you can use to determine the x-intercept. All right. Any questions? Okay, it's just basics of equations. Okay, just substituting y equal to 0. If you have got values, okay, then maybe it can become clear. But if you just memorize that equation, it makes things very easy. Like you are still young, you should be able to memorize that. All right. Then the y-intercept. Remember, you get this when x is 0. So the equation is f of x equal to a over x plus q. So what we are going to do here is substitute x equal to 0. If we do that, we put f 0 equal to a over 0 plus q. Obviously, what does this tell you? Can you be able to, do you think it will be possible to find the y-intercept there? No. So what that means is that the y-intercept doesn't exist in grade 10. Any hyperbola does not have a what? Y-intercept. So this is undefined. Therefore, there is no y-intercept. Okay? And this is also an indicator that there is an asymptote. Okay? So I'll give you a reason why. Because because the x-axis is an asymptote, or rather, it's not the x-axis, the y-axis. For that, it's the y-axis. So the y-axis is an asymptote. Okay, just take note of that. This is the y-axis is an asymptote, and the y-axis is with an equation, which I'll talk about later on. And I think I told you before that the y-axis has got an equation. Okay, so you will never get a hyperbola in grade 10 that touches the y-axis. That's not possible. If you're asked to sketch the hyperbola, it will never touch the y-axis. Okay? Any one of the two curves will never touch the y-axis because the y-axis is an asymptote. Also because in grade 10 we only concentrate on vertical shift of the graph, right? So it will never touch the y-axis. But next year now, in grade 11, then we can have horizontal shift, whereby you can have a y-intercept for the hyperbola. But for grade 10, this is the scenario. There is no y-intercept. Okay? Right, so x-intercept, y-intercept. Let's move on to the equations of the asymptotes. Equations of the asymptotes. Okay, now we have got two equations. There's a horizontal and there's a vertical asymptote. So let's start with the horizontal asymptote. Okay, let me write equation of horizontal asymptote. Right, that equation. Now, since the horizontal asymptote, right, it has to start with 1. The equation has to start with 1. It's a horizontal asymptote. Therefore, the equation will be y equal to q. Okay? Whatever the value of q is, okay, that's the one you put there. So if you're given the equation, all you have to do is just identify the value of q. Then you put it there. Remember, q can be positive or negative. If q is positive, means the asymptote will be above the x-axis. Q is negative, the asymptote will be below the x-axis. Right? Then equation of vertical asymptote. Now the equation for the vertical asymptote, okay, it's actually x equals to 0 because the y-axis is an asymptote. Okay, so the equation will always be x equals to 0. Always, for this grade, it will be x equal to 0. And just to remind you, this is the y-axis. Okay? Please, the y-axis is not an equation, but the y-axis itself has an equation. And that equation is x equals to 0. So if you're asked to write down the equation of the vertical asymptote, you can't say y-axis. You write x equal to 0. Okay? These are equations. Right? Don't say asymptote equal to. The equation must start with a y if it's horizontal or x if it's vertical. If you write anything else, I'll give you a 0. Okay? So make sure you are aware of this. Right? Now, especially the fact that this one here doesn't change in grade 10. Okay? any hyperbola, its equation of the vertical asymptote is always x equal to 0. But for the horizontal asymptote, it depends on the value of q. Okay. Then, lines of symmetry. Now, the hyperbola also has lines of symmetry. Okay, it's got lines of symmetry, and there are two of them. Any question before I get on? So, equations of axes of symmetry, please, this is plural. Okay, axes of symmetry. Right, there are two of them. So, let me say number one. Let me start with the one which has got, okay, maybe I need to draw a sketch as well. Okay, let me draw a sketch. Okay, let me draw a sketch. So let's start with number one, the one with the positive gradient. Right? When I say the one with the positive gradient, please just allow me to consider the value of A as a positive. So if it's a positive, then we sketch it in the first quadrant and the fourth and the third quadrant. Right, so I'm sketching here for the case where A is positive. Now, the equations of the asymptotes, right, they are straight lines. They pass through the origin. So this will be like one of them. Right? The other one, if you have a negative gradient, will be something like that. Now, these two straight lines, they've got general equations. Right? So the general equation for the one with the positive gradient, it will be y equal to x plus q. Okay? And then for the one with the negative gradient, it will be y to be y equal to minus x plus q. Please just remove this one here because I'm just going to summarize that. So I just took a case where the value of A is positive. Right? Your two axes of symmetry generally, I've just drawn them here passing through the origin, but they may not always pass through the origin. They pass through a point where the asymptotes intersect. Okay, so this case is a case where both the x and y axes are asymptotes. Therefore, all four, they are functions. The x-axis becomes a function because it's an asymptote. The y-axis becomes a function because it's an asymptote. The line y equals x plus q is a straight line, it's a function. Y equals minus x plus q is also a straight line and it's a function. So all four of them, they intersect at a common point. The axis of symmetry and the asymptotes intersect at a common point. And that point will be somewhere there. Okay? If our horizontal asymptote was above the x-axis, it means that these two lines will intersect with both asymptotes at a common point which is above the x-axis. Okay, or if it was below, or say that the horizontal asymptote was below the x-axis, all four will intersect at the common point below the x-axis. Okay, but the general equations are this. Please be aware that this is a general equation of a line of symmetry with a positive gradient. And this one here is the general equation of a line of symmetry with a negative gradient. Okay? Because we are in grade 10, we don't talk about horizontal shift. Next year, when we shift the graphs horizontally, then this will change slightly. We introduce another constant, which is the p. But for grade 10, that's what you need to know. Okay, you may be asked to write down or to determine the equation of the line of symmetry. Okay, it's not very difficult. Again, but you've got a question. Now, before I carry on, you need to be a master of your linear function. Yeah, you need to be a master of your linear function. By end of this week, okay, I expect you to become a guru of the linear function. Right? If you had problems last year, then those problems must cease to exist now. Right? Okay, so we have got that. Well, I think that's it. Right, but I just need to tell you the basic functions. The basic functions. So here, okay, basic graphs. All right, your two basic graphs are y equal to 1 over x. Okay, y equal to 1 over x. If you sketch that, it looks like this. First curve in the first quadrant, second curve in the third. Okay, and the second one is y equal to minus 1 over x. Please, for this one here, be aware that the numerator will be negative. That's what it means. X can never be negative, but the numerator will be negative. So, because of that, we sketch it to look like this. You have first curve in the second quadrant, and then the second one in the fourth. Okay? So those will be the equations. But I think let me talk about domain and range as well. Okay, so after G, let me move on to H. The domain and the range. Okay, these two are your basic graphs. Okay, all the functions have got like the basic graphs. So we're going to be playing around with these two, move them up and down. Okay, in grade 10, we won't move them in a horizontal direction. Okay, if I were to add the lines of symmetry here, both of the equation will be y equal to x, and the other one will be y equal to negative x. Right. Can I carry on? Okay, domain and range. Right. This one now, the domain and the range are slightly more complex when you're writing them down. Okay? So, let's start with the domain. The domain will be x is an element of real numbers, but x can never be 0. Okay? X can never be 0 because we have a vertical asymptote. Okay, so the two curves will never touch the y-axis. Therefore, x can never be 0. Okay, always in grade 10. That's your domain for the hyperbola. For the range, it's going to be slightly different. But the format is almost the same. We can write y is an element of real numbers, but y will never be equal to the value, okay, at the horizontal asymptote, which will be a q. Okay? Y will never be equal to q because y equal to q is an asymptote. It's a line. So because it is an asymptote, the two curves will never touch that asymptote. Therefore, y can be any value from minus infinity up to positive infinity, but it can never be equal to the value of y at the horizontal asymptote. Okay, there is a connection. Okay, by now I'm sure you might have noticed, I hope you did, that there is a connection between the domain and the range and the equations of the asymptotes. There is a connection. Okay, so for the range, since the equation of the horizontal asymptote is y equal to q, when you write your range, you exclude the value of y at the horizontal asymptote. Also, for the domain as well, x can be any value from minus infinity up to positive infinity, but you have to exclude x equal to 0 because there is an asymptote there. Right? So make sure you're aware of this, because generally this is a very important part which you may get in tested examination in grade 10. You may be asked to write down the domain or the range. Right? And usually it will be 2 marks. Okay, so I think I've discussed everything now. The next thing is just to do some examples on sketching. Is there anybody who has got a question? Okay, so let's sketch now. So sketching. Okay, I've already sketched the basic graph, so I'm not going to worry myself with that. Let's sketch, let's say f of x. We'll start with one where the asymptote, okay, the horizontal asymptote is at y equal to 0. So f of x equal to, okay, let me start with say 1 over x. Let me include the vertical shift, right? So say plus 2, like that. Alright? So we want to sketch that. Now before you sketch, you need to know the shape first. So the shape A, which is the numerator of that fraction part, is positive. So the shape looks like this. You have the curve in the first quadrant and another one in the third quadrant. Right? So that's my shape there. Then obviously my y-intercept is undefined. Okay, I need to determine the x-intercept. Right, this one we determine it when f of x is 0, always. Okay? But I think I gave you an equation, but I'm not going to use that equation. So 0 equal to 1 over x plus 2. Then you have to take that positive 2 to the left. You get minus 2 equal to 1 over x. Now, if you know your equations well, do you know that you can just swap the minus 2 and the x? Do you know that? If you know your equations well, you don't need to do any cross multiplication. Right? So we just swap the minus 2 and the x, and you get x equal to negative a half. So what this means is that one of the two curves will pass through the point where x is equal to minus a half. Your y-intercept is undefined. Okay? Y-intercept is undefined. Or you can say no y-intercept. Okay? There's no y-intercept. Then the equations of the asymptotes, equations of asymptotes. Now move on to the next page. Equations of asymptotes, or rather, let me say, equations of asymptotes. Okay, so if I write HA like that, if I write HA for our own purposes, horizontal asymptote. But when you, in your case, you don't write HA equal to no. The horizontal asymptote is y equal to q, but in this case now, our value of q is this, positive 2. Therefore, our equation of our horizontal asymptote will be y equal to 2. Okay? The equation of the vertical asymptote is always x equal to 0. You don't have to think, right? Then we also have the lines of symmetry, their equations. So equation, or rather equations of lines of symmetry. Okay, you can call them lines of symmetry or axes of symmetry, okay? So, alright, so I gave you the basic equations. Remember, the two equations that I gave you, the first one with the positive gradient, is y equal to x plus q. Therefore, for our question here, it will be y equal to x plus 2. One with a negative gradient, y equal to minus x plus q. For this question, it will be y equal to minus x plus 2. So you have to know how to draw those straight lines. Okay? Generally, we use the dual intercept method, which is the easiest. Okay, so on the next page now, I'm going to sketch. It's not necessary to draw a table. Yeah, but it's not necessary. If you want, you can do that. But if you want to draw the lines, you don't need a table. At this stage, I expect you to not use a table. Okay, because these are sketches, you don't draw them to some degree of accuracy. No. You just, for the straight line, find the y-intercept, x-intercept. Take a ruler, draw in those 2 points, and draw lines beyond those 2 points. That's all. You don't need the calculator. Okay, y equal to 2 is above. So let me okay. Let me go back and have a look at my values. My y equal to 2. My x-intercept is minus a half. And then for the lines of symmetry, x is 0, y is 2. Y is 0, x is negative 2. Okay. So let me calibrate it this way. Right. So if I say minus 1 here, you are supposed to use the ruler. 1, 2, and I can put a 3 there. So it will be negative 3, and 1, 2, then minus 1 is 2. Okay. All right. So first thing, when you are drawing a hyperbola, you start by drawing the horizontal asymptote first. And you don't use a continuous line to draw the asymptote. Okay? So our equation of our horizontal asymptote is y equal to 2. So My asymptote is going to be this one here. Okay, you can label it y equal to 2. Once you draw the horizontal asymptote, you need to know that your first quadrant will now be between the y-axis and the horizontal asymptote. So the area bounded by the y-axis and the horizontal asymptote becomes your new first quadrant. The second quadrant is also the area bounded by the y-axis and the horizontal asymptote. I hope you are following that. The third quadrant is also an area bounded by the horizontal asymptote and the y-axis. Then your fourth quadrant, horizontal asymptote and the y-axis. So, first thing, draw your horizontal asymptote first when you are drawing any hyperbola. Okay, remember, the vertical asymptote is our y-axis, so we don't worry about that. Then the next thing, identify your x and y intercepts. But in this case now, we only have an x-intercept at -1/2, which will be somewhere there. Okay? Now be aware that your shape, the shape looks like this. So I've got the first curve in the first quadrant, the second curve in the third quadrant. Right? Now, because of the shape, it means my first curve, I can draw it. Here, this is my first quadrant, so it will look like, right? That's the first curve in the first quadrant. Now, because we have got an x-intercept here, it means that when I draw my second curve, it goes that way. Okay? It goes in that direction. I'm going to try and see if I can pass through that point. It's not perfect, but it looks something like that. Okay, that's the second curve. It passes through the point where you have got your x-intercept, which is that point. All right? There's no y-intercept. Okay? Then the next thing is to draw the lines of symmetry. Now, the lines of symmetry, they actually pass through the point where the two asymptotes intersect, which in this case, for our diagram, that point of intersection is going to be this point here. So our two asymptotes will pass through, our two lines of symmetry will pass through this point. The lines of symmetry and the asymptotes intersect at a common point. Okay? So when I draw, be aware that my two equations, and just to refresh you a little bit, my two equations of symmetry are y equal to x plus 2 and y equal to minus x plus 2. Both are straight lines, remember? So, let me start with the one with the positive gradient. If I remember, 2 is your y-intercept. Remember that 2 is your what? Your y-intercept. So it means that it passes through that point. Okay? This 2 here, it's a y-intercept. So what's the x-intercept? If you want to find the x-intercept, you put y equal to 0. Okay? If you put y equal to 0, you get x equal to -2. So -2 is here. Right? Are you following that? Then, no need to use a table. Okay? There's no need. It's a sketch. You waste time. So when you draw it, my line won't be that perfect. I wish I could draw one which is perfect, but it looks something like this. You have got rulers. Okay? So this will be the line of symmetry with a positive gradient. And then you can label it y equal to x plus 2. Okay. Then the one with the negative gradient, I'm sure you can see that the y-intercept is also a 2. Okay? It's also a 2. And this value here, that's our y-intercept, which is also this point, right? Our x-intercept, if you substitute y equal to 0, you get x equal to 2, which will be, well, let me use this one. So it will be this point. So when you draw it, it will be something like that. Start slicing from the top. Okay, so it looks something like that. Right, then you can label that line y equal to minus x plus 2. Right, so that's how your hyperbola will look like. Okay, in most cases, you won't be asked to draw the lines of symmetry unless it is specified. It's an aspect that I have to talk about. And, since it's my first lesson, I need to emphasize that concept because it comes back next year in grade 11 and also in metric. It also comes back. So if you understand it now in grade 10, it makes things easier. So just to summarize here, the lines of symmetry and the equations of asymptotes intersect at a common point. Right? You can add the domain and the range of this graph. Right.